All right, everyone, welcome back to part 2 of area of a parallelogram. Hopefully you got a chance to watch video 1, and if you did, or if you haven't, I should say, I suggest you go and watch that video first. This video is going to be dealing with more of the word problem type questions that are going to be coming up in the next 2 worksheets. So the worksheet for today, or the first one after your practice sheet, is specifically dealing with area of a parallelogram, but it's going to get into a couple different word problems, and I'm going to go over both of those examples today. The first word problem you're going to see is one that looks generally like this. You're going to have a parallelogram. It's going to give you a couple of measurements, but it's going to be missing one. So instead of asking for the area, this time you're going to be asked to find the height or the base. It doesn't matter which one, as long as it doesn't matter if it's missing the base or the height. The process to finding the answer is the same. As usual, we start, like all of these questions, with our formula. Area equals base times height. Now we just fill in what we know. So we know the area is 40. So we're going to enter in 40 meters. We know the base is 10 meters, but we don't know the height. So the question we need to ask ourselves here is, what times 10 equals 40? Another way to do that is 40 divided by 10 will also give you the same answer. So you think to yourself, well, 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, so it must be 4. So 40 equals 10 times 4, which means the height equals 4 meters. Okay, so when you get questions like this, use your formula, but decide at the time which one you're going to multiply by. Sorry guys, I realize there's a glare on the screen. I apologize. I got the windows behind me. This is the first time for me trying it here in the class. Hopefully you can still read it. Now, once you have given those a try, we will do a couple more practice ones here. So let's try a different parallelogram. All right guys, here is our next example. Let's see if I can get this camera up a little higher here. All right, guys, here's our next parallelogram. This time around, we have the area, the height, but we're missing the base. So the question here is going to be, what is the base? And just like the last example we did, let's go with our formula. Area equals base times height. Let's fill in what we know. The area is 27. The base we don't know, and the height is 9. So the question is, what times 9 equals 27? What times 9 equals 27? Now, you could also do 27 divided by 9, because that will also give you the answer. So I would work with 9s. Well, 9 times 2 is 18. And then at 9 times 3, well, look at that. That's 27. So 27 equals 3 times 9, which means the base equals 3 meters. All right, so in these types of questions, just work with what you know and work your way backwards. So again, we don't know the area, or we know the area, but we don't know one of the measurements. So what times that measurement we do know will give us the area. Let's try one more. All right, guys, here is our last parallelogram example. And this time around, we have a parallelogram that has an area of 56 meters squared, a base of 8, and a height which we have not determined yet. So let's work with our formula. Area equals base times the height. 56 is the area. The base is 8, and we don't know the height. So we need to ask ourselves, what times 8 will give us an area of 56? Or we can divide 56 by 8, which will do the exact same thing. So again, if you know your 8 multiplication tables, 8 times 8 is 64, so that's too much. So 8 times 7, however, is 56. So 56 equals 8 times 7, which means the height is 7 meters. 7 meters. So again, guys, these are just very basic examples. If you don't know one of the measurements, work your way backwards. Okay, we're going to get into another type of word problem you're going to see on the next sheet. All right, guys, this is our next example. So on your sheet, you're going to see something very, very similar to this. It says that the person is designing a CD cover. I don't think any of you guys buy CDs anymore, but you know, we'll use a different example here. So Peyton is designing a cover for a card. So she's making a card for somebody and she's designing a cover for it. And on the cover, there are a number of small parallelograms. And each one of these small, and on the little thing here, I just put PAR to shorten it. Each small parallelogram is 2 by 6 meters. So what is the total area of the small parallelograms? So the first thing we need to do is, when we get a question like this, is find the area of one of them. So let's go with area equals, that same formula I told you we're going to use a lot, base times height. Area equals, now we don't know which one the base and the height is, but we can make a guess here. The smaller end must be 2, and then the height here must be the 6. So it's going to be 2 times 6, which means area must be 12 meters squared. This should actually be centimeters, because there's no way that card is in meters. 12 centimeters squared. That's probably too big. I'd probably say millimeters. Let's go with millimeters. Doesn't matter. You see the process. So here's 12 millimeters. So each one of these little parallelograms is a total area of 12 millimeters. But that wasn't the question. The question was, what is the total area of all of the small parallelograms? So to do that, we need to first figure out how many we have. Well, we have 1, 2, 3, 4, 5. Well, we have 6 of them. Okay. And each one of them is 12. So I'm going to take my 12 millimeters for one of them and multiply that by 6 of them. And then 72 millimeters. So again, you may need to go check your multiplication on the side, or maybe you want to do it quickly in your head. However works for you. Please avoid calculators here, guys. You really should not need them. When we do these back in class, especially on our test, there is going to be no calculators. So 12 times 6, 72 millimeters is the total area of all of the small parallelograms in this example. All right, we'll try one more example. All right, guys, here's our last example for the day. Let's see if I can get this camera a little closer here. It's kind of tough to read. Let's see how that works out. All right, hopefully that's a bit better. So this one is, Jason is designing a patio. Now, each blue brick in this patio is 3 by 5 meters. What is the total area of blue bricks? So Jason's designing a triangular patio, maybe in his backyard. He's put in some blue bricks, and he wants to figure out what the total area of those blue bricks are, because maybe he's going to go need to pick them up. Let's start with our formula. Area equals base times height. Because what we're going to do first here is find the area of one of these bricks. Now, again, doesn't tell us which one is 3, which one is 5, but we can assume that the 3 is going to be the height, and 5 is going to be the base, okay? So 5 times 3. But again, if you switched it, it wouldn't matter. You're going to end up with the same answer. So area equals 5 times 3 is 15 meters squared. So each one of those blue bricks is a total of 15 meters squared. Now, that wasn't the question. The question was, what is the total of all of the blue bricks in this patio? So let's figure out, we found one of them, which is 15, but we want to find all of them. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's a total of 9 of them. And each one is 15. So we need to figure out 15 times 9 in order to give us the correct answer here. Again, maybe you need to go over to the side of your paper and write out 15 times 9. 9 times 5 is 45. 9 times 1 is 9. Plus 4 is 13. So the total area is 135 meters squared of blue bricks that Jason needs to find in his patio. So again, guys, these types of word problems, and there is going to be one on this next sheet, all you need to do, find the area of one of the bricks or one of the whatever they give you the measurements for, and then multiply that by how many there are in total. And that will give you your answer. Guys, if you have any other questions about this, please, during our class meeting, stay with me after the meeting and we could talk one-on-one, and I could try to walk you through some of these examples together. Otherwise, that's pretty much it for the next worksheet, and hopefully you guys can do well on these. Now, I had one student ask me, well, if there's decimals, do I multiply them? The answer is yes, you definitely multiply the decimals, okay? So don't drop them. We're multiplying by decimals here. You know how to multiply by simple decimals. There's nothing complicated here. Otherwise, guys, we'll talk to you soon. There will be one more video before the final textbook questions come out, and then we will move on to triangles. All right, we'll talk to you soon. Bye now.